So continue with our containers in Python. Now we're going to talk a little bit about dictionaries. It's another data structure that we have there. And as in lists, it's also a mutable object, which means that we can alter the values and the size and so on and so forth. Dictionaries, they're composed of key-value pairs similar to a map function in Java, where we have, we have an index, and for that specific index, for that specific key, we have a value. Before we start doing this, let me delete this cell right here, we won't need it. So let's say we have an empty dictionary like this, or you can define your dictionary as simple as saying that, well, that's a dictionary, and that's it, right? The thing is, they're both equivalent, which means they are pretty much the same thing. So if I say, well, is empty equals to x, and if we try to print that out, we're going to see that that's true, because this here dict in parentheses, the same thing as the curly brackets one, right? But our dictionaries, we are interested in storing stuff in our dictionary, right? So we can have something as in B, and we say, hey, this is a dictionary, and we'll have the value here for 1, and we're going to have the value for 1, and 2 here, we'll have the value of 2, oops, sorry for that, 1 here. This is pretty much that specifying the values explicitly. So let's say we have 1 here, and we have 1 like this, and then we have 2. It's pretty much the same way, right? Oops, that has to be outside of our dictionary. And if you want to check it out if both of them are the same, you can simply just verify like this, and you see that both structures, they represent the same thing. You don't necessarily need to go there and use a word, also always a word and a specific value. You can do other clever things and as use that probably a name if it makes sense to your logic. And let's say that the cat right here, it's cute. And then our dog is gonna be furry. And well, that's it. Suppose after that we're gonna add some new elements more, and then you can access every element inside our dictionary simply using the keys that we have, because for every key we are able to retrieve a specific value inside our list, or you can even verify if that given element is inside our dictionary as in the form of a presence, yes or no. So for the first case here, we use cat as the index for our dictionary, so we retrieve that key and print it out its value. And for the second example, we check if the key or the string of cat is within our dictionary, right? Different than lists, you can pretty much change and add a new value. So instead of doing an append, you can simply create a new key, and for that new key, you just go there and create a new value. So as simple as this. And if you want to check it out how that worked out, we see that we have all the elements that we previously had, as in cat, cute, dog and fury, and fish, now it's wet, and we have all of them there. Of course, this is not the only way of adding and retrieving an element. We can use the dictionary and use the get to get the proper ID that we want. So let's say I want to get the fish. And if we print that, we'll see that fish, it's retrieving the wet here. The thing is, sometimes we want to get out an element that's currently it's not there. So let's say if we want to get out monkey, but we don't have monkey, nothing happens because this element is not there. If you want to send a message saying that this element is not there because it's not applicable for whatever reason, if you can run that, you'll see that now we have NA being displayed here for us. Okay. You can also remove the element, whatever element you want. So now let's say we're taking out element from D and we're removing the element in which key is a cat. And then if we do this there, nothing happens because this element does not exist anymore. So if we go there and print it out, we'll see that cat is not there. So the deleted function here, it's taking care of the element according to the index that we are providing. Okay. Again, this is only possible because dictionaries, they are a mutable object. If it was the other way around, we wouldn't be able to go there and alter the object. Which means that, let's say we have the dictionary D, but now let's take another element inside. Let's say that dog now is not the value of fury, and now we have a different value. Let's say the value now it's 42, and we can run this here, and we should have put the print there, but in any way we'll see that now the element which the key value was dog here, the value now is 42 instead of fury, 30 as we had it before, right? The same way we iterate over lists, we do a for and we can simply retrieve every element inside a list. We can do the same thing for our dictionaries. So let's say for animals, or let's say for X and Y for the sake of simplicity in our dictionary here, and we retrieve all the items, and we're gonna print it out all those items. So let's say we're gonna print it out here, X and Y, right? And let's run this, guys. What we have, when we use and retrieve the elements from our dictionary through the items function, we are retrieving the pair of key as an X and value as in Y. So when we print it out, we have the name of the variable, like the key, so dog, and then the value that we currently had, which is 42. And since we did not alter fish, it still has the same value as in wet. All right. Another thing that we probably should mention is the same way we can do list comprehensions, you can do dictionary comprehensions. They work somehow similar to lists, but the final result, instead of being a list, is going to be a dictionary. So let's say we have a list here. It goes from 0 to 4, and we have let's call just a even dictionary. Why not? So what are the elements? What is the structure that we want to return? First of all, it's a dictionary. And then what is our dictionary composed? It's composed of a key and the value. The key, it's going to be X itself. And I want to take the value and do the power of 2, but not for all the elements, of course. I want to do this for all X inside nums. And of course, the value of X has to be divisible by 2, so it has to be an even number, right? So we go there and we print out this. And as we can see here now, we have for every element, for every pair of key and value, we have the key, which is the elements that we have in our list, and the values is the X itself multiplied by itself. So we have here, of course, for all the numbers that are even, so 0 times 0 is 0, and with the index 0, the 2 is 4, and 4 is 14, and so on and so forth. okay? The same way as lists, our dictionary comprehensions can get as complex as the logic that you're using. Probably also we should mention that when you're returning the items, you're actually returning both key and value. Sometimes it's more interesting just to return the values or just the key as they have. All right, so thank you and happy coding.